This is just an informal video to address common issues on the Math 293 midterm in winter 2023. So a couple of things that came up a few times is, when are vectors parallel? There were a variety of answers I accepted for this, but in my opinion, if I'm given two vectors and I want to see if they're parallel or not, the quickest way is to change both into unit vectors by dividing by the magnitude and see if they're the same. So if they are parallel, then you should get the same unit vector. Now, it's possible they'll be opposite signs, but that's, just pointing the opposite direction. They'll still be parallel. Another question was talking about the idea of a unit versus a non-unit vector. And a lot of people were very focused on the procedure of how we turn a vector into a unit vector. There's a lot of talk about divide by the magnitude, divide by the magnitude. And that's not wrong. I give you the credit. But the key here is that I want you to understand the concept that a unit vector is a vector with magnitude 1. So it's a vector where we're really only looking at the direction, basically. We've turned it into magnitude 1, and so we're just looking at what direction it is pointing. That seemed to be missed a bit. And of course, if the dot product of two vectors is 0, then they are orthogonal. Another issue that I noticed, and this is more related to question 2, is that students did not seem totally clear on the fact that if you have a plane, for example, here's a plane, it's really important that you understand that this vector that goes with sort of the coefficients here, the A, B, C, is not on the plane. This is normal or orthogonal to the plane. So there was a lot of work being done to try to find a vector that's orthogonal to or normal to the plane, but this actually is. And so the reason that when we find the angle between two planes we can use those is not because they're on the plane, it's because they're both normal to their respective planes. Another thing that came up, if we skip ahead a little bit, we had some issues on number 6 where I'm giving you a surface and I want to understand the shape and just like the traces and things like that. So let me scroll this up a little bit and get some space. For this particular problem, the question I gave was this. And the issue that I saw was that people were trying to really just test a bunch of values. But in the video that I shared with you guys on how I like to do this, what I recommend you do is you look at the overarching shape. So for example, for the XY traces, what you're doing is you're saying, well, what if I keep the X and Y here and I bring the Z over here? Let's think about what this might be for different values of Z. So the smallest that Z squared is ever going to be, of course, would be 0, because if I plug in anything negative or positive, it would just get bigger. So Z is 0 is the smallest it goes, everything else goes bigger. So therefore, this whole side is going to be 16 or bigger. And also, if I notice that this is a minus sign here and this is a plus, that's enough to tell me that this should be a hyperbola. So the XY traces are hyperbolas is really what I was looking for. The XZ traces, I was looking for a little more subtlety, although I was fairly generous with my grading on this. If we isolate X and Z by subtracting y squared from both sides, and then let's just multiply everything by -1. A couple of things to keep in mind. Notice that these are different, and so therefore this wouldn't be circles. Notice they're both positives, so this wouldn't be hyperbolas. This would be ellipses. Okay, we would get an ellipse. However, we also have some restrictions on what y is able to be. So y can't be too small. The smallest y could be is 4. And if y is 4, we get a point. So that means we get, if y is 4, we get x squared plus 16z squared equals 0, which is basically 0, 4, 0. Similarly, if we look at negative values, that is also a point. And that brings up that it's also okay for y to be less than negative 4. So anything really where the absolute value of y is 4 or bigger is going to give me an acceptable answer. The ones where we're actually at 4 will give me points, and the ones where we're strictly greater than 4 or less than negative 4 will give me ellipses of growing size. And the YZ traces are, same idea as really the XZ traces. If we were to go through that, we end up with, again, hyperbolas. So what we get here is a hyperboloid of 2 sheets. And as far as why is it of 2 sheets, it's because of the fact that when we look at this region right here, let me highlight this. When we look at this part right here, there's values of y that don't have any values of x and z that go along with those. So it creates a gap there. So if I look at any of the values along the graph where y is between negative 4 and 4, then there's a gap. So that's why we get 2 sheets. All right, next up, what I'd like to take a look at is the stuff to do with cylindrical coordinates. It is coming back. We're going to be dealing with cylindrical and polar quite a lot in the second half of this course. And so I really do need you guys to understand this. Overall, I felt like people were missing the boat a little bit on what to do with the negative value of r. So there is more than one correct way to think about this that will land you in the right place. I had some students who were saying, go backwards by that value r, this is to graph negative 2 3/4, 2. Go back 2 and then go around by, take that bar and kind of revolve it around by 3 pi over 4 and then go up 2. And that is fine. The other way you can also think about it is as doing the revolution first. So same idea where you still have the negative 2, 3 pi over 4 and 2, but you could begin by thinking of revolving this by 3 pi over 4 to get to this sort of direction. And then as far as how far you go along, you go 2. But instead of going 2 in the positive direction, you would go 2 backwards from there. So go backwards 2, which would put you in that region over here, which really goes along with going backwards by pi over 4. You could think of that. And then go up 2 from there. So this actually puts us, by the way, in the 4th octant. So that right there would be the sketch, and it would be in the 4th octant. Now, the reason that I put that in there was actually as a little bit of a helper for you guys to try to help you get the correct answer for part B. It was a bit of a hint of, hey, don't forget to think about where points are located before you give final answers. So if I take a second and I look at the point negative 2, 2 root 3, 4, then that's an XYZ in this case. And the first thing I will always ask you to do is think about what octant this is in. And so this is X is negative 2, Y is positive, whatever 2 root 3 is. So that puts us over here. And then we want to go up by 4. Notice that this is in the 2nd octant over here. And in the 2nd octant, we're looking at values that are between pi over 2 and pi, right? If you picture starting here at 0 degrees, and then going pi over 2, pi, 3 pi over 2, 2 pi, kind of going around that circle, then this is supposed to be giving me values that are between pi over 2 and pi. Now, I had a lot of people who correctly got me the R by doing this work right here. But notice that this actually gives me, what? 4 plus 12 is 16. That gives me 2 possibilities for R. So when I go and give my final answer, I have a decision to make about whether to put a 4 here or whether to put a -4 here. And that decision is going to be based partly on what my angle is. And so now I want to go ahead and look at what is the solution for tangent theta equals y over x, in other words, -√3. And what a lot of people did was they just said, okay, it'll be arctangent of -√3. But the problem is that arctangent only ever returns values between -pi over 2 and pi over 2. So it's going to give you a value that's over here. But we know our point is actually not over there. We know our point is over in the second octant. So if you got that value, you got a value that was over here. And what I'm looking for instead is for you to notice that it would be pi more than that. So you should be getting like a negative value for that. And just a quick reminder of how to get the exact value. You can always think of this as -√3 over 2 over 1/2. So this is like saying what is going to give me as a sign value on the unit circle, -√3 over 2. So that would be down here out of my -pi over 2 to pi over 2. It would give me something down here in this region, and it would be sine is the -√3 over 2, cosine is the 1/2. In other words, I would have -pi over 3. So what I'd really like here is pi plus -pi over 3. In other words, 2 pi over 3. And a +4, and then up 4. Another acceptable answer, of course, would be you could do -4 if you decided to keep the -pi over 3. And I didn't have any directions that weren't allowing that, so that would also have been full credit. So that subtlety of like, where is my point? Just don't be in such a hurry to throw arctangent in as your final answer. I don't plan to do detailed clarification on what are the other ones? Number 8, part A and B, or entirely on number 9, but I want to address something that came up with the limits problem for a few students. I had a lot of students do this really well, but I had a couple of students make a couple of mistakes that I want you to watch out for. So one mistake that I saw people make, and your Calc 1 should have reinforced this same thing, is that I had a few people who said, okay, direct substitution leaves me with 0 over 0, so therefore it does not exist. And that is wrong. You cannot conclude because you get a 0 over 0 or an indeterminate form that the limit does not exist, ever, with limits, and you couldn't do it in Calc 1 either. So that's not an approach. That just tells us we have to do something else. Another thing that people tried to do with this is to use paths. But the problem with using paths, all the problems that I gave you in the homework where you were using paths had the limits approaching 0, 0. And so if you were picturing on the coordinate plane, what are some different paths to approach 0, 0? You could approach along the x-axis, the y-axis, the line y equals x, or really any other line y equals mx. And they would all pass through the point, right? They would all approach that point. But you can't use those same paths to try to approach 1, 1. You can't use those same paths to try to approach -4, -5. So the reason some of you were using paths and getting different answers and then concluding does not exist was inherently just a flawed approach. You can't really use paths that don't approach your actual point that you're trying to approach. So one of the things, I'm not really planning to give you paths problems where we're not approaching 0, 0. So if you see a problem that is not approaching 0, 0 in my class, you can rest assured that I'm not looking for you to prove the limit does not exist using paths. You'll be looking for something else. It could be factoring and canceling, could be rationalizing, could be replacing x squared plus y squared with r squared and simplifying from there. There's a few different approaches that remain, but paths will not be it. All right, last but not least, I wanted to take a look at number 15, which was the Lagrange multipliers / extrema problem. And so this is the problem where we have f of xy is equal to x squared plus 2y squared minus 2x plus 3. And our constraint is this circle of radius root 10. So for part A, I was looking for a sketch of a circle where the radius is square root of 10, and the interior of that circle would also be included as the constraint. And just as a note, we can use Lagrange multipliers on the boundary, which is the edge of the circle. And then we have to use first partials to try to find critical points inside. In other words, when we're looking at this part. And so for part B, that's where we're going to look for the potential extreme values on the boundary using Lagrange multipliers. Now, first thing to keep in mind for Lagrange multipliers is that overall, I thought people did pretty well on this. You would find the first partial for x, and then for y equals lambda times, and then the first partials for the constraint. And then I always recommend that you list, and this would be worth some of that partial credit, that you list the system of equations that you get as a result of this. And I always list the actual boundary as that as well. That's one of my parts of my system of equations. So we have 3 equations and there are 3 unknowns, which are x, y, and lambda. And so now we start kind of going through, and the first thing I asked you guys to do in all this stuff I was sending out through the instructor notes was ask yourself, is it possible for x to be 0? Is it possible for y to be 0? It's always a good place to start. So if x is 0, then if I take a look at this first equation, this would become this, which is false. So x cannot be 0. That means that if I want to, if I find it useful, I could divide through by x. How about y? If I replace y with 0, do I also get a contradiction? And the answer is no, that's actually okay. It makes it true. So y equals 0 is one of the things that makes this true. So let's pull that out a little bit more. 4y equals lambda times 2y. Those of you who went through and divided both sides by 0 and ended up getting lambda equals 2 lost a solution. This should lead to 2 solutions. And an easy way to avoid having that problem is to subtract everything to one side and then factor. So this would lead us to both solutions. Y is 0 or lambda is 2. Let's bring that back up over here. If, and we'll just kind of block that off, if y is 0, then let's also go back and remember to find out what x has to be. So that means x is plus or minus root 10. So if we look at where that is on my constraint, that means I want to test here and here. Now, we don't automatically test everything. Those points I have to test because they make my system of equations for Lagrange multipliers true. What about if lambda equals 2? If lambda equals 2, then I'm not jumping right to the x squared plus y squared is 10. I'm going to go grab my other equation. And this is going to give me 4x. In other words, I need to solve this, and I get x is -1. But that's just giving me an x value. So now I want to go back to my, x squared plus y squared equals 10 and replace that and determine what y values go along with that. And that would be plus or minus 3. So that means that I have -1, 3, -1, -3. So that gives me 2 additional points on this boundary to test, -1, 3, and -1, -3. So I get 4 points that I'm going to test that are on the boundary. And I'm going to continue from here and try to identify some things on the interior as well. So I'm just going to slide that up a little bit so we can still see most of it. And for part C, we're not going to take those same first partials and say, well, what if we're looking for critical points? So critical points would be the things that make my first partial 0. And so, or undefined, right? And so that would mean I have 1, 0. Now 1, 0 is not on the boundary anymore. It's actually right here, but it is on the interior. So I'm going to keep that point and I'm going to test it as well. So my final job here for part D is to test all of these in my original function. So I put in, -1, 3, -1, -3, -√10, 0, √10, 0, and 1, 0. And I try to figure out what's the biggest output and what's the smallest output when I am looking at the original function, which I don't think I can scroll up to right now, but that original graph of this function of the surface that I'm trying to find the extrema over. Mostly people who got some of the partial credit on that part. That wasn't the issue. It was the division by 0 was an issue. People were losing that and getting a little stuck. All right, so that's all I'm sharing out via video. I hope this is helpful clarification for people. But of course, remember, you are welcome to reach out to me to set up a time or show up in an office hour if you want to take a look at your test. I will not always have your test with me. I'm not going to carry them around everywhere I go after this point. So if you want to see your test in a future week, just make sure you let me know so I can make sure to have access to that.